Hello, future AI artists. Today we're going to dive into the character training. The SDXL large model requires a high-performance graphics card, which many of you may not have. Therefore, we'll explore how to train models using cloud-based GPUs. For those who prefer to use their local GPUs for training, that's perfectly fine as well. The parameter configuration for model training is the same for both local and cloud-based setups. First, open this page, register an account, and log in. Once you've successfully logged in, you'll see a page like this. Click on Go to Secure Cloud. I've already selected a template, but you can choose the same one under Templates. Next, select a server with a large GPU capacity, which refers to VRAM. Generally, I recommend choosing one with more than 20 GB, but keep in mind that the more powerful the performance, the higher the cost. RTX 3090 server is fine. Click Deploy. Here, you can choose your template. This is Chris from the future. Recently, RunPod has adjusted the interface layout. You can click on Explore to choose the template you want to use. For example, the first one. Deploy to GPU Cloud. After that, you can select a GPU. Okay, these are the main interface changes. You can continue. Click here to modify the configuration. I've set the volume disk to 30 GB, and I recommend setting the container disk to 30 GB as well to avoid running out of memory. Click Set Override. Continue and deploy. Wait for the server to finish deploying. If you can't deploy right away, it might be because the server you chose is in high demand and another user has deployed it before you. In that case, you can wait a bit and try again, or choose a different server. Click Connect and select Connect to Jupyter Lab. Some of you might see a Not Ready message. Just wait a little while. Open the terminal. Open this page, copy the first command, paste it, and press Enter. Copy the second command and perform the same operation. The system deployment might take a while, approximately 15 minutes. Now, let's prepare the training data. Click this icon to create a new folder named Data. If you need to rename it, you can right-click and choose Rename. Then enter the data folder and create 4 subfolders like this, making sure to capitalize the first letter. This naming convention allows you to use my prepared training configuration files directly. To prepare the large model files needed for training, double-click to enter the model folder, click the plus icon and select Terminal. Go to this page, find the SDXL large model, right-click, and choose Copy Link. Type wget, press the spacebar, paste the link you just copied, and hit Enter to start downloading the large model. Next, open this page and copy the link for the SDXL VAE file. As before, type wget, space, paste the link, and press Enter. After downloading, you'll need to rename the file and remove everything after the question mark in the file name. After that, you can close the current terminal. I'll now introduce a little trick for training with third-party models. You can add the keywords SafeTensors and Hugging Face to your search engine queries to easily find the third-party large models you're looking for. Then, copy the model's download link. Back to our project, it's time to import the training set. Enter the Images folder, create a new folder, and name it in this format. The number 15 indicates that during each learning round, the AI will study each image 15 times. I'll explain later how to choose this value. Open the folder and drag and drop the prepared training set into it. Once you see the installation complete message, you can copy and paste this command into the terminal and press Enter to start Koya. I will simply skip that from this video, and you will find every command I mentioned in the course resources. Makes it easier for you to operate. Then, drag and drop my prepared training configuration into the Data folder. Click this link, and you'll find that the interface is identical to the locally deployed Koya. First, load the configuration file by clicking on the Lora tab. Make sure not to get this wrong. Right-click the file and select Copy Path. Enter a /, which is a crucial step. Paste the path you just copied and click Load. You'll see that the path has been automatically filled in. The Model Quick Pack contains download links for some commonly used models. If you choose this, the program will download the selected large model before starting training, which is usually slow. That's why I use a custom path. For Save Trained Models As, usually choose SafeTensor. If you're training the SDXL version Lora, make sure to check SDXL. If it's the 1.5 version of the large model, don't check any options. Let's quickly review the Folders section. The image folder, output folder, and logging folder correspond to the paths we created in the data file. For the output name, it's recommended to name it after the model followed by a version number, such as version 1.0 for the first version. In the parameters section, batch size refers to the number of batches trained simultaneously in each round. The higher this value, the faster the training speed, but the accuracy will decrease, and it will consume a lot of GPU performance. It's typically set between 2 and 4. If you encounter an out-of-memory error, reduce this value. Epoch indicates the total number of training rounds. Without using regular images, the total number of training steps for the model is the number of images multiplied by the repeat number multiplied by the total epoch number divided by the batch size number. The advantage of using a higher number of epochs is that there are many options when the model training is complete. The downside is that it can lead to decision paralysis. Mixed precision depends on the type of graphics card. If it's an NVIDIA RTX 30 series or above, fill in BF16. Save N epoch indicates how often to save the model during training. If you fill in 2, the model will be saved every 5 rounds. Caption extension is the extension name of the captain file we prepared. Regarding LR scheduler, you only need to know that constant and cosine with restart work well. For the SDXL model, it's recommended to choose Add Factor as the optimizer and add this command to reduce memory usage during training. The LR learning rate is something you need to pay attention to. The larger this value, the more the model will learn. Overfitting refers to the situation where the images generated by the trained model are almost identical to the original images, making it difficult to produce new elements. Underfitting, on the other hand, refers to the situation where the model differs significantly from the images in the training set. Generally, the value filled in is 0.0004, at most 0.0009. This depends on the value of your batch size. If your batch size is less than or equal to 2, then this value should not exceed 0.0007, otherwise it is easy to get overfit. The text encoder learning rate is generally set to 1/10 of the LR learning rate. However, due to entering train UNet only in the optimizer extra arguments, it means that the text encoder is not trained during training, so I can fill in a value arbitrarily, and I will choose this value. The option Cache Text Encoder Outputs has been added to the configuration file, so it is not selected here. For training non-photo level characters, we select 64 network rank. This value is generally 128 for photo level characters, 64 for non-photo 3D characters, and 32 for 2D cartoon characters, respectively. Setting network alpha to 1 can make the model perform better in representing non-character elements like background when generating images. In the Advanced section, pay attention to the file path for VAE. Firstly, ensure that the downloaded VAE file name matches exactly with the path here. Secondly, if you're training the SD 1.5 version of the model, replace it with the corresponding VAE file for SD 1.5. Now, look at samples. It generates an image with a specified prompt after saving each model file. Let me simplify the meaning of this prompt for you. The first part here is the negative prompt, specifying the width and height of the image, seed value, CFG value, and sampling steps. After all this, let's click the Start Training button. You can see the training has begun. A quick reminder, if you encounter an error, it's likely due to the VAE name in the path being different from the downloaded VAE name, or the data folder in your directory having a different naming convention from the video. Pay attention to uppercase letters. I recommend fixing it and then clicking Start Training again. Also, since this is running on a cloud server, if I can do it, you can too, provided all your operations are correct. If you see prompts like steps and %, it means your configuration is correct and you can proceed. During training, you can check sample images in this folder. Of course, I haven't completed the first round of training yet, so you won't see it for now. Double-click on the prompt file to view and edit your sample prompt. After editing, press Ctrl and S to save, and it will take effect in the next round. Now, let's fast forward to the first sample image. The prompt here indicates that the sample image is currently being generated. Let's take a look at the generated results. It seems quite different from our main character. Because we only have 15 images, repeat is set to 15, and the batch size is 2. So based on the formula I explained during the epoch, you can quickly calculate that the first epoch trained is approximately 113 steps. You can see that the number here is indeed 113. Well, let's skip to the final result. Now the training is complete, a total of 10 epochs. You can compare the first and last images. Note that our sample prompt didn't specify her attire, but here she is wearing armor. This shows that it has associated our character with wearing armor, which is closer to our training set. Locate the last epoch. Remember, the last one has no number. Right-click and choose Download. Move the downloaded file into the Lora folder. Open Stable Diffusion. Let's try the model we just trained. Add the negative prompt from our training set caption. Add our trigger word. Let's start without adding the trained model and see what the generated images look like. Enable this tiled VAE. The fast decoder feature can speed up the decoding process, making the final step of image generation faster. Next, I'll also check if unnecessary features like the control net are turned on. Confirm that everything is okay. Generate the image. Next, let's add the model we just trained. Click on Lora, enter the model name, and select the model. Then, generate the image. You may notice that the color of her pants is completely different from the training set. That's because our prompt mentioned silver metal leggings. Let's remove that now. With this change, the generated character should closely resemble those in our training set. Let's try a different seed. Since our training set only has one pose, we can use the control net to have her strike different poses. Drag the prepared pose into the control net and check Enable. I will use a open pose image here. This way the preprocessor should be set to none. If you want use some reference image like photo, you should set to open pose. Press Ctrl and Enter to generate the image. This way, she will strike another pose. Also be noticed that currently, SDXL model do not work well with ControlNet, not like SD 1.5 model. Alright, that's pretty much the practical part we need to cover for this lecture. Now let's take a look at some other results I've generated. This one has a closer resemblance to a comic style, with our character holding a sword standing on a snowy mountain, exuding a heroic vibe. I didn't intentionally adjust the seemingly problematic parts of the scene here because I want to take this opportunity to impart some meaningful insights which are often confusing for newcomers. Let's talk about colors. You'll notice that her collar is red, unlike our training dataset. This is because, firstly, we had fewer training steps, making it difficult to fully control various details of the character. Secondly, the color of the character itself can be easily influenced by other elements in the scene, especially red, which can significantly affect other elements in the scene. So it's important to use it cautiously. A good solution is to reduce the weight of certain color prompts, such as reduce its weight to 0.5 or even 0.3. This can help reduce their impact on other elements. Of course, if you're proficient in using the in-paint feature after the previous lectures, you can easily adjust these. The quickest way is to use image editing software like Photoshop or Affinity Photo to manually fine-tune the details of the scene, then import it into Stable Diffusion and lower the denoise strength to integrate it. I believe you're already quite proficient in these techniques. In another scene, our character is sitting in a medieval tavern, and you can see her facial details fitting well with our training dataset. We can also change the character's attire, like having her wear a robe while lying on a bed holding a cute plush toy, or having her sit on the grass. Through these, you can see that even with fewer training steps, the characters we train have a strong consistency. Of course, all of this hinges on the quality of our prepared training dataset. Only with scientific and meticulous preparation can we truly yield good results. Lastly, once you've completed your training, it's advisable to close RunPod to prevent ongoing resource consumption. Simply return to the RunPod interface. Click on the Stop Pod button here. Please note that it will continue to incur charges based on the space your current pod occupies. To completely halt charges, you'll need to click the Terminate button here and confirm by clicking Yes. This will cease all further cloud storage fees, and this is very important. Well, that wraps up today's lecture, and I'll see you in the next lecture.